Hello everyone. This is the second tutorial session of the Probability Foundation for Electrical Engineer. Who instructor is Professor Krishna Jagannathan from IIT Madras, and I am Satyavikram Pratap Singh, a PMRF Research Scholar at Department of Energy Science and Engineering, IIT Bombay. So this is the second tutorial session. Technically saying, we have seen that tutorial 0, then 1, then second tutorial session, and this will help to solve the assignment 3, which of the problem we have kept. I have kept here. There are basic problem which will be helpful to solve the assignment 3. Okay, so the basic problems here, the structure will be such that I will be showing few of the problems and give the few minutes to solve that problem, and after that we will see that how to approach that problem, and that how it will be helpful for solving the problems and all. Okay, without wasting time, let's start with the first problem. Here it is the first problem. Okay, try to solve this. After that, we will see how to give the solution for this and approach the problem. Okay, try to solve this. If you read the option, what is actually saying that which of the following is true for sigma algebra, and option are such that option A, it must contain the empty set, and B, closed under the complement and countable union. Second is saying that it must only contain the open sets. It only contains the finite set. It cannot contain the entire sample space. Okay. So if you see the solution for this, the option A is correct, which is saying that it must contain the empty set and cannot be closed in the complement and countable unions. Let's see that why it is actually saying. So in the yesterday lecture, we have I have given that there are three criteria to be judged that whether is certain omega which is lying in a sample space of F is actually a sigma algebra or not. Okay, so that is the thing is that first if you see the collection of subsets, this says that so the phi is belonging to the F equivalently. Phi is belonging to this omega is actually belonging to F. It means that there are functions. Suppose I am having a set psi omega, that is 1 2 3 4. So the possible subset of this is a 2 to the power mod of omega, that key it is 2 to the power 4, that is 16 sets are possible, and phi is one of them, and phi is belonging to the omega is belonging to the F, if you see that. Okay, so this is the first criteria. And second is that if A is belonging to the F, the A complement will also belong to the F. Suppose here the A is there and the rest of space will be the A complement. So if the A is belonging to omega belonging to the F, okay, so it means that A complement will also belong to omega belonging to F, kind of. Okay, so the second is the closed under the complements. Okay. Second, third option is that A1, A2, A3, which is belonging to the F. So the union of that. So it means that when you are having a subset set F, it is having the subset multiple subsets. That is A1, A2, A3. That is kind of, so union of all the subsets which is disjoint. So you can add it up and it will form the overall sample space. Okay, so it is basically the a1 a2 which is belonging to the F, and the union of all these terms which is from the n to 1, n is equal to 1 to infinity an, this belong to the F. Okay, this property is known as the closed under the countable union. That is very very important to understand. And from 2 and 3 you can say that this closer under the countable intersection, that is follows the De Morgan's law. Okay, so it means that option A is actually belonging to that. Okay, it's not being that you only contain the open set, it can be closed set as well, and it can be converting can take the infinite set as well, cannot entire sample. It is very very false that it can contain the overall sample space of the system. Okay, so why the first option is correct, other options are wrong? So it must contain the open set, but the problem is that sigma algebra need not to be tied to be topology at all. Okay, so it means that Borel sigma algebra, which is generated by the open set, with that also contain the closed set as well. If you see the what we have seen in the here, like this A B set kind of, that it having the half of an interval, closed set, singleton sets, and maybe other sets as well. So not only the open sets, but it is having the trivial sigma algebra is the phi omega doesn't reference the open sets at all. Okay, why the C option is actually incorrect, that it only contains the finite sets, false, because sigma algebra can be infinite, even uncountable sets as well. Okay, so the Borel sigma algebra is the uncountable, and the closure under the countable union alone forces the presence of infinite set whenever there is infinitely many non-empty members are there. Okay, and the option D, when you see that it does not contain, that is the very very wrong. That in fact that omega which is being placed inside of the F can be formed the overall sample space of the F. Okay, because if you see the omega inside of the, if it is a is also belonging to the F, and A complement will also belonging to the F. Okay, let's take one of the example. If you see the omega 1 to 3 is there, F which contain the subsets of it, that phi omega and 1 2 3 kind of, then the complement of is the 1 2 3 which is also belonging to that. When you take the 2 3 complement, it is 1 which is also belonging to it. It means that countable union, any union of the member stays in the F, and F is a sigma algebra. Okay, so this is the overall structure of the first problem. Let's move forward and see the second problem. Okay, try to solve this, take your time. Okay, let's see this problem. What is saying that the Borel sigma algebra on 0 to 1 is generated by all closed interval, all open interval, or singleton sets, the set of rational number in between 0 and 1. Okay, so if you see the criterias like that, how you define this Borel sigma algebra. So let's see that. So the Borel sigma algebra on a set X, which is being defined at the smaller sigma algebra containing a given collection of set. It can be for suppose I'm taking 0 and 1, which typically generate the collection such as the AB. A belonging to the 0 to B and B is belonging to between the A and less than or equal to 1. Means you if you see the all open intervals in the 0 and 1. Okay. So the sigma algebra which is generated by the C naught denoted by the sigma C naught. Okay. It contains the open intervals. It contains the all closed and half open interval via set operation, all countable union and intersections of such intervals, and many more that is complicated sets which are obtained from these operations. Okay, so the generated sigma algebra is the Borel sigma algebra on 0 1 written as a Borel of B such as that 0 1. Okay, of this 0 to 1. Okay, so this is a basic terminology to understand, so that the option, if you see that all open intervals here in the in between the 0 and 1, so option B is actually correct. Why other options are false? Let's see that closed interval can generate the same sigma algebra, but the standard definition start with the open interval. That's why this option is actually incorrect. And if you see the singleton generates only the countable sets much smaller than the B 0 and 1. Rationals alone generate a trivial sigma algebra which with only four sets for a smaller 0 to 1. So that's why the few examples of that I've taken that AB using complement and countable union we obtain the half open and close interval repeating set operation which yield that Borel sets and all. Okay. So that's why these options, if you see the B option is correct and A, C, D is actually false. Let's move forward and see the other problem. Okay, this is important because Lebesgue measure of a singleton set, it is a different concept. If you know that, try to solve this, and after that we will see that. Okay. Okay, let me explain what is actually it is. Okay. Oh, let me give you 30 seconds more to solve that. After that, I will give. Okay. Let's explain. Okay. So this Lebesgue measure formalizes the concept of length on a real line. When you're having a real line here, okay, okay, real line that actually started that depicting the length of this real line. So if you see the singleton set that is X contains exactly one point and had no length, it means that it is a point that uh, So, explaining one point and has no length, that exactly one point, and it is don't having any length. Okay, so formally, if you see that B is belonging to this set that 0 to 1, 0 to 1, 0 to 1, that is the open side of from side of the 1 and 0, and we can represent the B as a this if you see. Okay, so the Lebesgue measure is that a measure of b minus 1 by n comma b, which is a closed interval, is 1 by n. Taking the limit, if you see that m of b limit 1 by n is 0, it means that every singleton has a Lebesgue measure 0. Okay, so why the other option is not correct? If you see here the first a option is saying 1 0 depend upon the point and undefined, so that's why this b option is actually correct. Okay, it's actually limit when you take the here and b limit 1 n tends to infinity 1 by n is equal to 0. Okay, so the 1 is actually the wrong because a single point had no length, and depend upon the point that it also wrong because all singleton have the same measure that is actually equal to the 0, and it is undefined the wrong. The Lebesgue measure is well defined for the all singleton. Quick example that in 0 to 1, if you see the set zero point 0.5, because zero point 0.5 is belonging to in between the 0 to 1, just like zero point 0.1 or pi by 4, adding or removing a point from a set does not change the Lebesgue measure. Okay, so that is the important point to be understood. Let's move further. Try to solve this. In the problem, it is saying that out of these four theorems, which theorems actually allows the extension of a pre-measure of a full probability measure, either a Bayes theorem or Frobenius theorem or Kolmogorov Giro's one law or Carathédori's this extension theorem. Okay, try to see that which of the theorem, if you know the theorems actually, then it is actually pre-measured to the full probability measure. Otherwise, I will explain it in the solution part. Okay, take 1 2 minutes to understand that, and after that we will solve. Okay, let's see the solution. And if you see that why different theorems are there, so you can go through the theorems. You can see that but the correct option here is the Carathéodory's extension theorem. Let's see that what is theorem actually says. Okay, so it is a fundamental result is a measure theory that allow us to take a pre-measure that is actually a set function defined on a algebra of sets satisfying finite or a countable additivity and extend it uniquely to a full measure on a sigma algebra generated by that algebra. Okay, formally if you see the if f naught is a algebra of subsets omega and p naught colon f naught is equivalent in between the 0 to 1 satisfy, so its a probability will be equal to 1 and countable additivity on the f naught. Okay, so then there is a exist a unique probability p on a space that is omega and sigma sigma algebra f naught such that the pa is equal to p naught for all a belonging to the f naught. Okay, so it means that this theorem also is important for Lebesgue measure because starting from a symbol set that is a finite union of the intervals. Okay, so let's see that why other option is not correct because of the other theorems. Because the Bayes theorem, if you see, it relates to the conditional probability, not about the measure extension. So that's why the Bayes theorem not come into this picture. If you see the Fibonacci theorem, it is also concerned about the changing the order of the integration in the double integrals. Okay, when you are changing the integral from the from an internal side to the output side based upon the area where we are integrating, that's why the second C option is not correct. If you see the option D, that is Kolmogorov zeros one law, because it deals with the tail event which is having a probability 0 or 1. Okay, it's not about the constructing the measures. Okay, so if you take the example as well that to define the Lebesgue measure on the 0 to 1, start with the f naught, which is a finite union of a open interval that is AB. Define P naught, that is AB is equal to B minus A, and Carathéodory's theorem extend P naught to the entire Borel sigma algebra, giving the full Lebesgue measure. Okay, so these are the points to be understood for this solving of these problems, because this theorem is actually relating with the measure extension. That is very very important. Okay, try to solve this next problem. In this problem, it is saying that the set of a rational numbers in between the 0 to 1 and the Lebesgue measure has a measure, whether it is 0, 1, infinite, depend upon the rational chosen. So we have already seen this kind of problem, but I request you to solve this. Okay. Okay, let me give the solution for this. The option is saying that ki set of rational number in between the 0 1 under Lebesgue measure had a measure 0 1 in infinite and depend upon the rational chosen. Here, if you see that we have already seen, okay, that if you remember this, what we have taught here like this, if you take the limit which is being defined Lebesgue measure that k open interval of b minus 1 by n comma b in the open interval, here it is closed interval is 1 by n. So if you take the limit of the n tends to infinity 1 by n, it is becoming 0. So in the same manner, if you see here as well, the Lebesgue measure is based upon the length only. So the set of rational number in between the 0 to 1, which is denoted by this uh, uh, q, and it is countable, okay, from the measure theory that any singleton number that is q which is having Lebesgue measure is actually 0, and a countable union of measure 0 sets also has measure 0, okay. So it means that key when you take the limit of n tends to infinity 1 by n, it is going to be 0. The option a is correct. Why other option is not correct? So one is wrong because one would require a covering the whole interval length, so that's why this is wrong. Infinite, which is wrong because it's a measuring in between the subset which cannot be exceeding the one, so that is also false. And if you see the depending upon the rational chosen, this is also wrong because all the subset of the rational which is countable, it also measured the zero value, okay. So that's why it is actually false. So if you take the example that even through rationals are dense in between the 0 1 because there are variety of number 0, 0.1, 0.2, 0.5, infinite number of rational numbers are possible. So their total length is actually 0, so they contribute no measures. Okay, that's why. Okay, let's move forward. Try to solve this problem. Okay, let's see the what is actually the problem saying that okay, in the infinite coin toss model, the sample space which is having the omega, the option A is saying the numbers which is being with 0 to 1 to the power n for the finite n, or 0 to 1 which is belonging to the infinite side, and close interval of 0 to 1, or a set of the integers. Okay, when you see the all the sets, like what is actually the current correct way to of a correct solution for this problem, it is saying that in the infinite coin toss model, each coin is actually result of tossing a coin infinitely many times. Okay, either when you are getting, we can represent it the head as a 0, a tail as a 1. So the outcome which is there in the infinite binary sequence, that is omega 1, omega 2, omega 3, where omega I, which is having a probability of something to find out, or where omega I will be belonging to the 0 1 for each I. Okay, so that's why the set of all such sequences denoted by this omega is equal to 0 to 1 infinity. This is uncountable set since it corresponds to all function from n to the 0 to 1. Okay, why the other options are false? 0 to 1 to the power n. This will be simple space for a finite number of tosses, non-infinite toys. 0 to 1, that is corresponding between the infinite binary expansions. So the set of integer will be completely which is unrelated, and this cannot be represented the infinite sets. Okay. So if you take the sequence that 0 to 1, 0 0 1, it means that toss 1 head, toss 2 tail, toss 3 head 0, toss 4 is a head which is 0, toss 5, so on it is forward. Okay, infinite sequence. Try to solve this problem, take your time, and let me know if you have any problem. if you read this problem, what is saying that in conditional probability, that is P, such that ki occurrence of A is dependent upon B is defined only if the PA is greater than 0, PB is greater than 0, P in A intersection B is greater than 0, or the both A and B are disjoint sets. Okay, so it means that ki, conditional probability, if you see the what is definition, PA is actually defined as the PA intersection B divided by PB, okay, is equal to PA, that is B. Okay, so for this expansion to be well defined, the denominator of the PB must be non-zero, because if it is zero, it become infinite. So that the existence of this condition probability will not be there. Okay, so that is undefined, that is saying. So this is why we can only have the condition on the events B that having the positive probability. Okay, so the option B is actually correct, because the PB should not be equal to 0, it should be always greater than 0, because the probability is itself is going to be probability of any function. If you're taking A or B, it should be greater or equal to 0. Okay, and this PB will not be equal to 0. Okay, so to make it is positive. Okay, so that's why the option B is correct. Why the option A is called PA is always greater than 0. That is by default property. A intersection B is also greater than 0. If A and B are disjoint, then it will be 0, because the PA intersection B will be equal to 0. Okay. If you take the example also, let's take the PB as a zero point 0.4, the intersection B is zero point 0.1. So conditional probability of A B will be equal to zero point 0.1, because the intersection is zero point 0.1, and divided by zero point 0.4, that is equal to the 0.25. Okay, and here if probability B is 0, okay, so this probability, condition probability of A such that the occurrence of B is dependent upon that, so it will be equal to undefined. Okay, let's move forward, try to solve this problem. Okay, let me give the solution for this. It is saying that when the two events A and B are independent, which option is actually correct? Okay, so the option B is actually correct for this. That is, P A intersection will be equal to P and B. What the question is saying that if the two events, suppose I am taking a event one and event two. Okay, event one is tossing a coin to get head. Event 2 is uh, rolling a die for getting 6. So the probability of getting 6 here is the 1 by 6, and also here the getting the head is 1 by 2. Okay. But it is not saying in the problem that when you are tossing a coin and get the head, then you roll the die. What is not saying that the occurrence of event 1 is not dependent upon 2. So suppose it will be said that toss the coin only when you get 6 while rolling the die. Okay, so here the problem is that the occurrence of one event is dependent upon the second event, so they are not independent, they are actually dependent. So this property will not hold in this case, that is probability of A intersection B, which is equal to the probability of A multiplied by probability B. So here the probability of A intersection B occurrence is equal to 1 by 6 multiplied by 1 by 2 is equal to 1 by 12. Okay. If you see the answer also, that independence means the occurrence of one event does not affect the probability of the other. So formal definition that A and B actually they are independent. That is probability of A intersection B is equal to probability A multiplied by probability of B. And this equality must hold for the both event to be independent under the probability measure P. So it simply implies that P, suppose P conditional probability A such that B is already occurred, it will be equal to A intersection B divided by PB. Okay. So the probability of A intersection B is the probability of A multiplied by probability of B. So divided by probability of B, it will get cancelled out, though it will formally become the probability of A. Okay. Only when the probability B is greater than which is already been there, probability cannot be equal to 0. This is simple criteria to be used here. Okay. So similarly, if you see the probability of B such that A is already occurred, it will come out to be probability of the B. Okay. So this is the probability of the A when the A and B events are both are independent. Okay. Let's move forward and try to solve the other problems. So here also that if you see the tossing of the two fair coin, first coin gets heads here. For if both are independent, both the coins, so their probability will be 1 by 2 multiplied by 1 by 2, similarly equal to 0.25. Try to solve this problem. So here the question is Leibniz measure of the Cantor set is actually zero, 1, infinite, not defined. Okay. What is saying that key A is true, the Cantor set K is formally by repeatedly removing the open middle third from the remaining interval that is 0, 1. First step is that remove 1 by 3, 2 by 3, then the length reduced by 1 by 3. Step 2 is that removing 1 by 9, 2 by 9 and 7 by 9, 8 by 9. So total length will be removed as 2 by 9. Then remove the 4 interval like each of the length that is 1 by 27. So total length will be removed by 4 by 27. So the total length which is removed when you add it up 1 by 3, 2 by 9, 4 by 27. So it's a kind of GP. Geometric progression series. So that will be equal to 1 by 3, 1 minus 1 by 3, 1 by 2 by 3. It will be equal to 1. So the total length which is removed from that system is 1, and the length or Levesque measure of what it is actually remaining the Cantor set is actually 0. Okay, that is the overall total length 1 minus which is being removed, that is 1. The overall system is 0. When you see the option 1, that is actually wrong because the length would never be removed. No removal took place, means the removal should be there. 1 minus 0 cannot be there. Okay, so infinite is also wrong because it is subset in between the 0 to 1. So measure should be less than or equal to 1. And the third point is that it is not defined, which is wrong. The contest it is Borel miserable. So its measure is well defined. Okay. Give example that even though the Cantor set is uncountable and has the same cardinality as 0 to 1, its Levesque measure is 0. It's big in point but small in the total length. Okay. Let's move forward. If you see the next problem, here it is saying that in the law of total probability, that is set of the BI. uh, okay, so there are the four options that it should be independent in the partition the sample space and having the equal probability, or it can be disjoint only to the finite subset. Okay, so take your time and try to see this law of the total probability that is being set as the BI. So see that and let me know which option is actually correct. So in this problem, if you see what is saying that law probability where it actually hold that you must follow that. So the law of total probability says that if bi, which is I belonging to the integer I, is a partition of the sample space that is omega, with PBI is greater than 0. Okay, probability will be always greater than 0, and you are having a sample space which is omega. So for all I, which is the bi which is being possible, suppose this is b1, b2, b3, b4. So then an a any event a is equal to summation of I a by bi multiplied by bi. Means what is saying that probability of a will be equal to probability of a by b1, occurrence of a such that the probability of b1 is already being occurred, multiplied by p1, plus probability of a by b2, probability of b2 plus dot 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 the nth term which is being there, probability of bn multiplied by probability of bn. Okay, so this is all being actually a partition of the sample spaces which is being hold for the law of the total probability. And the partition is mean that ki, when you are having a two, here let me take another pen. Suppose this is the b1, and another place is the, this is the b2. Okay, and both are independent, so the probability of bi intersection bj, the element which is common in between is the phi for all I multiply I does not equal to the j, which is mutually disjoint sets. So it covers the all the entire sample space when you take the union of that. Suppose this is b1, b2, when you take the union of all these subsets, so it forms the entire space of omega. Okay, so this condition actually ensures that the event which is occurring a intersection of bi breaks a into the disjoint pieces whose probability add up to the pa actually. And why the other option? Because it independence, being independent, that is problematic. That is, independence not required for the law to be whole, only disjointness and covering omega is actually matter. Have equal probability, that is also not required because the PBI can differ. Okay, and the D option, be disjoint only for the finite set. Actually, this law requires the full pairwise disjointness, not just the finite subset. Okay, let's move forward and try to solve this problem. Okay, let's give the solution for this. In the question, it is saying that if a set having the countable number of points in the Lebesgue measure, its measure is actually 0, 1, infinite or undefined. So we already know it will be equal to 0 summation of all the values here being defined. We have already seen this problem. So I have kept it deliberately to make you understand that to revise it and go through the in the depth with the concept. Okay, try to solve this. Try to solve this problem. Okay, let me explain that. Carat-Theodory's theorem requires the initial function P naught to be countably additive on F naught, only finite additive defined on the all subset of omega, not negative only. So correct answer should be, it starts with the A option is actually correct. That is countably additive on the F naught. So the theorem actually starts with a phi mature P naught, which is defined on a algebra F naught of a subsets of omega. For P naught to be extended uniquely to fully measure on the sigma algebra, that is sigma F naught, it must satisfy the P naught omega. P naught omega is equal to 1 by the summation of all the probability, which is normalization of the probability measure, and countable additivity on the F naught. At if AI is the pair were disjoint in the F naught, then the union of all the subset which is belonging to the F naught actually. Okay, and all the probability their union is the summation of the probability of the A1, A2, A3. That is actually this property holds. So this property ensures that the measurement is the consistent when extending from the simple sets like finite union of the intervals to more complex measurable sets. Okay, let's move forward. Let's move forward. Uh, let's move forward for this. Try to solve this problem. me explain that. The Borel sigma algebra is actually what is being asked, that equal to the power set of omega, smaller than the power set of omega, larger than the power set of omega, or equal to omega itself. Okay. So the Borel sigma algebra B omega is actually the smaller sigma algebra which contain all the open sets or open interval in R. The power sets 2 to the power omega contain all possible subsets of omega. Okay. Many subsets of omega are not Borel sets. Certain non-measurable sets like the vitality set. Therefore, B omega is actually subset of the 2 to the power omega. Okay. So the omega is equal to 0 to 1. Borel of 0 to 1 contain all the intervals, that is countable union and intersection of such plus sets derived from them. So it is not clearly being considered subset of it between the 0 to 1. So if you see the other option, that is actually the equal to the power set, that is false, because not every subset is Borel measurable. And the larger than the power set, which is, this is not possible at all, because the power set is largest possible collection of the subsets. Okay. And equal to the omega itself, because this is not making any sense, that it is set of point, not a connection of the subsets. Okay. So let's move forward and try to solve the different sets. This is already we have seen. Okay. This also we have seen. This also we have seen. Try to solve this. This one independent. Then one must try to solve this. So in this problem, when you see that if two disjoint events are independent, okay, then the probability will be equal to zero. So it means that when two independent sets probabilities are there, so probability of A intersection B is will be equal to probability A multiplied by probability B. If A and B are disjoint, it means that ki A intersection B will be 5 and P A intersection B will be equal to 0. Okay. So independent condition means कि it is equal to zero. It means that कि either of PA or either of PB will be equal to zero. So both probability having probability vote, which is not possible because they are disjoint event. The summation could be one, but not a single unity can be one. Okay, and both have the equal probability. They are not irrelevant because equal probability doesn't imply that independence of the disjoint event, and also there some must be one. Okay, not required, but some can be less than or equal to one in the disjoint cell. Suppose I am taking one example, that is PA is equal to zero point 0.4 and PB is equal to zero point 0.6. Then the PA intersection B will be equal to 0, and independence would be required when the PA are multiplied by PB is 8.4 multiplied by 0.6, which is false unless one probability will be equal to 0. Okay. Try to solve this problem. Let's see this problem. It is saying that the sigma algebra, which is generated by the collection C, is actually the largest sigma algebra containing C, smaller sigma algebra. Let's see the actually the correct option. That is actually the B is correct, the smaller sigma algebra. Uh, Seeing that why it is correct, that given the collection C of the subset of a sample space omega, the sigma algebra generated by C, which is denoted by sigma of C, is actually the intersection of all the sigma algebras that contain C. Okay, this makes it smallest sigma algebra containing C smaller in the sense of the set inclusion. It contains all the sets in C and any set that can be formed from them using the sigma algebra operation, complement, countable union, and countable intersection, that all will be corrected into that. Okay, try to solve this. This is a very simple problem, but try to solve this. So if in this problem the Bayes theorem actually relate with the option A, because you already know probability of A, finding of A such that the B is already occurred, that is probability of B by A dot PA multiplied by PB, where the PB is greater than 0. Similarly follows by the B by A such that K A is already been occurred. So that is overall systems, overall thing we which we could have discussed by the today. If you take the example of that, let's suppose the P having disease and P is a positive test when the disease is a 0.99. So probability of being disease and the positive test, that is 0.99 multiplied by 0.01 divided by 0.05, that is 0.198. So 19.8 will be such that even with the positive test the probability of having the disease is actually 19.8. Okay, so that's all for the today's session. We will meet in the next session and try to solve the assignment 3. If you have any doubt, we will discuss in the next tutorial session. Okay, thank you so much.